So, trig graphs start to become more useful once we begin to modify the length of the periods, because then we can use them to model all sorts of real-life scenarios where an object is oscillating or rotating or vibrating or something like that. So, we want to figure out how to do that now. And we have a variety of different examples here. So let's look at this first one, sine of 4x. The very first thing I need to do is figure out what my period is going to be. And I know my period is modified because if I look inside the function, I have a coefficient in front of my x term that will always change the period of the graph. So what is it going to do to my period? How can I figure out what my period is? Well, I can take my normal period of 2 pi for a sine and cosine graph, and I can divide it by that coefficient, 2 pi divided by 4, and I can simplify the number part of that, 2 and the 4. 2 divided by 4 is 1/2, so this is going to be the same as pi over 2. What that is telling me is that from 0 to pi over 2, I will have completed an entire cycle of the cosine graph. So I'm going to show that by labeling my fourth tick mark as pi over 2. And I can cut that in half and label that as pi over 4. And I can cut that in half and label that as pi over 8. Notice each time I cut it in half, I increased the denominator by a power of 2. And now I can count 1 pi over 8, 2 pi over 8, 3 pi over 8 right there. So I have my x-axis labeled, and now all I'm doing is sketching a normal sine graph. So you're hopefully starting to see that these graphs, based on how we're sketching them, oftentimes look pretty much the same. So it's super important that we are labeling them correctly. So I've now shown one period of this sine graph in between 0 and pi over 2. It has completed a full cycle. Now I want to show you something. I want you to think about something here. Imagine I showed a full 0 to 2 pi of this graph. Essentially what we've just said is it's going to complete a full cycle between 0 and pi over 2. So every pi over 2, it's going to do a full cycle. So if you look at this graph on the normal 0 to 2 pi, it's going to have 4 full cycles between 0 and 2 pi. So if you look at this, this is 100% the same graph I sketched a moment ago, but just between 0 and 2 pi instead of 0 and pi over 2. However you choose to do this is totally fine. I just want you to realize that depending on how you label this and the scale with which you choose to graph these things, they can look totally different even though they're really representing the same exact thing. But I think a good thing to point out is that, like, look, we've got one full cycle between there and there. There is a second full cycle, a third full cycle, and a fourth full cycle. Where am I seeing that I have 4 cycles in there? Well, I'm seeing it in that 4 right there. So let's think about that moving forward. Let's go ahead and do 1/2 of x. Using that same idea, between 0 and 2 pi, how much of a cycle is it going to have? Well, it's going to have 1/2 of a cycle. So if I do the algebra, I can take 2 pi and I can divide it by 1/2, which means taking 2 pi, and instead of dividing it by 1/2, I can multiply by the reciprocal of 1/2, which is 2. And so my period is going to be 4 pi, and that agrees with seeing that 1/2 coefficient. If that's saying 1/2 of the cycle will be completed in 2 pi, well then it's going to take 4 pi to do a full cycle. So we can label 4 pi, 3 pi, 2 pi, and pi right there. That's a pi, and that's a 2. Okay. And now I'm just graphing a normal cosine graph. So it starts at its max, and then it oscillates through the cycle. With every single tick mark, it goes through one part of the cycle between 0, 1, 0, and -1. And there we have our graph. So now let's look at C, another interesting case here. Notice that the coefficient is pi, which means to find my period, I could take 2 pi and divide it by pi to get 2. And this is interesting because now the units here are not in terms of pi, they are in terms of actual, what we would think of as like a normal real number. I mean, pi is a real number, but we're dealing with rational numbers here, which is interesting. And hopefully you can see how this idea might allow you to model the x-axis with, say, for example, seconds. So you can model with real time how something moves. But I'm graphing a sine graph. Now that I have it labeled, it's just going to look like a normal sine graph. That's kind of like what I'm trying to emphasize here. I can pretty much make anything look the same as long as it's labeled appropriately, then you're good. And so really we're just kind of figuring out how to label these things appropriately. Okay, so let's look at D real quick, the last one. This one will be kind of goofy. It's kind of like, notice, it's a combination between B and C. I've got a 1/2, but I've also got a pi in there. So I'm taking 2 pi, and I'm dividing it by pi over 2, which means I'm taking 2 pi, and I'm multiplying it by 2 over pi, the reciprocal. So notice my pi's cancel, and I'm left with a 2 times a 2, which means my period is 4. And so I can label it 1, a 2, a 3, a 4, just like that. I'm graphing a cosine graph, so it starts at its max and then it oscillates through its cycle. And bada boom, bada bing, we are finished. And there you have quite a few different graphs that you can choose to look at.